This is the video for Unit 7, Lesson 4, solving logarithm equations. So the goal is we're going to be using our properties of logs and what we already know about logs to solve equations in testing for extraneous solutions. So our steps that we're going to use is our first step when we see a log equation is we're going to try to isolate the log. If for our first couple we're going to see there's only going to be one log. We're going to do the inverse essentially and raise it to base b. So the inverse of a log is going to be an exponential. And then we solve, and we always want to test our solutions so we don't have what's known as an extraneous solution. An extraneous solution, which we've seen before, is a solution to an equation that's found algebraically, but does not satisfy the original equation. So if you'd like to pause and write that down, you're welcome to. But I'm going to dive right in and go through the first couple examples of solving a log equation. And these are going to be ones that have only one log involved. So our first one we have here is saying the natural log of 8x, and I'm going to put a parenthesis around the 8x, you don't have to, is going to equal 2. So our first step is to isolate the log. You can see it's already on a side by itself. We don't have anything else going on there. And now we're going to raise it to base, whatever base that is. So if you remember, ln is actually the same as log base e of 8x equals 2. We usually just write the natural log or ln. So I'm going to raise both of these to the e power. You could have also, if you wanted to, instead of raising it to the e, this is the same as if you chose to just rewrite it. And that's why we kind of practice that. So you can do it any way you like. So when I go ahead and rewrite this, and let's say I use that method, so I have here e squared is equal to 8x, right? Or essentially, I'm doing the inverse to get that. E is actually a number we already talked about. That's 2.718. And so now we're going to go ahead and solve for x. So I'm going to leave it in the e form just for now. But to get x by itself, I'm going to divide. So now x, when I go ahead and solve it, that's the same as e squared over 8. And in my calculator, I could actually put that in. So I have here e to the second divided by 8. And that way I don't have to worry about rounding along the way. And we're going to get this to be 0.92 if I round just 2 decimal places. And that would be it. For the next one, it's pretty much the same thing. So log base 4 of 3x minus 1. 3x minus 1 is being evaluated by the log is equal to 2. So again, it's like I'm raising it to a power of 4 or a base of 4. Or again, if you're more comfortable, you can isolate it and then rewrite it like we've been practicing with the inverse. So we end up with 4 squared is equal to 3x minus 1. 4 squared, we actually know what that is. That's 16. And now we're just solving a linear equation. So when I go ahead and solve that out, 17 equals 3x. And we're going to get a fraction or a decimal, which is fine. So as a fraction, it'd be 17 thirds. As a decimal, it would be 5.67. And then we're not going to have, this answer is going to work, but if we weren't sure, if I substituted this answer in, we would want to make sure we don't get any negatives inside here or answers that don't make sense. So when I put 5.67 here, I do get an answer that checks out. So 5.67 would be my answer. For the second or third example, same thing. So I'm going to isolate my log. So my log is right on the left side. I have a positive 1 that's not being evaluated by the log, but that's on the left side. So I have to first get it on a side by itself. So log base 4 of 2x plus 5 is equal to 2. So kind of similar to the last one. I'm going to raise both of them to a base of 4, or I can just rewrite it. So 4 squared is 2x plus 5. And then just simply go ahead and solve. This ends up being a linear equation. So when I solve it out, I get a decimal, which is fine. So I get 5.5. If I put 5.5 back in the equation, I want to make sure it works. it is going to end up checking out. A big flag is you want to make sure you get a positive value inside the parentheses when you're done, because you can't take the log of a negative number. For the other part of the notes, we're going to see, well, what happens when we have multiple logs here? So you could see in this first example, and we're going to see some factoring and some quadratics come back a little bit that we saw back in semester 1. If we have multiple logs, the ones we're going to see, it's like basically we have two logs with the same base and we're setting them equal to each other. So if I raise both of these, this is a base 10. If I raise both of these to a base of 10, it actually ends up, you're taking the inverse, and we're really just setting whatever's inside equal to each other. We then have an x squared involved, which makes it a quadratic. So we're going to move everything over to one side. I'm going to subtract 10. And then we're going to go ahead and try to factor it out. So what are factors that multiply to negative 10 but add to positive 3? This one's a nice, easy one to factor. 5 and negative 2. So we have x plus 5, x minus 2. And then we're going to set each of these equal to 0. So we get negative 5 and 2. And then we're going to go ahead and test that these work, right? Because we can't have negatives inside of a log. So if I went ahead and did, for example, let's say I did the log of 3 times negative 5 plus 10. I would get the log of negative 5, and I can't have the log of a negative number. So the negative 5 is actually an extraneous solution. If I tried it with positive 2, the positive 2 actually does work. I'd get log 16 equals log 16. So that one actually is going to work out, and I could try it in the other one as well. But especially when you get two solutions, you want to test that both of them end up working, because you can't take the log of a negative number. You get an error on your calculator. Number 5, there's lots of different ways you can do this problem algebraically. So this one, same idea. I have it, there are two logs equal. They're both a base of 5. So if I raise them both to a base 5, I'm setting these equal to each other. We're then getting all of these to be on the same side. So we have x squared minus 5x minus 8 equals 0. And then if we try to factor it, we're going to look to see, are there factors of negative 8 that add to negative 5? It's not factorable. And so we run into a situation where we might have to use something we used back in Math 2. Or we could even use our calculator. So if I want to solve this out, this quadratic, and this is unrelated to logs, this is just something, an algebra topic that comes in here, we can do one of two options. We can either do the quadratic formula, QF, and use our quadratic formula. Right, which we haven't seen in a long time, so we would just substitute all of those in. And then negative 5 squared minus 4, 1, and negative 8. All over 2 times 1. Another way you can do the same problem, though, is a lot of us have a graphing calculator now. So we can actually even use, if we don't want to use this, the other option is we can use our calculator. So if I wanted to use my calculator, I would just simply make this into a y equals. And my goal is to find the solution. So if I go to my calculator, I'm going to type in y equals. I can type in then the equation. So that's x squared minus 5x minus 8. And then if I hit graph, I might see the graph here. And our solutions are actually the x-intercepts, which we saw in our polynomial units, right? So we can do a few things here. We can either use If you want to use the trace button, it might not be perfect. You can see it doesn't go exactly. But we do have a nice calculator feature on here. If I do second and calc, I'm looking for a 0. Those are actually the solutions to this equation. And so this is kind of a helpful tip to know for like an SAT. If you need to solve a quadratic, you do have something that solves quadratics for you. So I would pick left bound. I have it on the left. I'm going to pick up spot on the right. And one of my solutions is actually 1.27. So I would write 1 point. You can see that where it's the x value. I'm going to write 1.27. And then my second one, I could do the same thing. I'm going to do second and calc. I need to find that other 0 that's on the right side. So I'm going to go ahead and do the same thing. So if I'm on the intercept, I'm going to go 3 units left, hit enter, go back to the center. And one solution I get is, and sorry, that other one was negative 1.27. We actually get 6.27. All right, now that we got these two solutions, we're going to see if these actually work out. So if I go ahead and type this in here, I want to make sure I'm getting a positive value. So if I go ahead and substitute that in, I have negative 1.27 squared minus 2 and then negative 1.27. I do get a positive answer. And then I'm going to try the second one out. So I have a 6.27 squared minus 2 times 6.27. And that one also works out. So we actually get two solutions for this one. That's a positive 6.27 and a negative negative 1.27. Our last example here, or last two we have, so the first one, I actually have to do a little bit of condensing. So I have two different logs, and notice the other one had a log equal a log. This one has two logs and a value, so I'm going to rewrite this. I'm doing subtraction, so this is the same as rewriting it as division. So I have 3x minus 2 over x minus 1 is equal to 4. And then I'm going to go ahead and rewrite this. I'm going to raise each of these to the 2, or you can do like the heart shape or the inverse. Either one works. And so 2 to the 4th is equal to 3x minus 2 over x minus 1. 2 to the 4th is going to give you 16 equals 3x minus 2 over x minus 1. I'm going to put parentheses so I don't lose anything here. And then it's the same as just really cross multiplying, or you can, a lot of other ways, you're just really doing the inverse. So we have 16x minus 1 is equal to 3x minus 2. And now we're just simply solving a linear equation. All right, if we go ahead and solve it, we get 13x is equal to 15 or 14. And then when we divide, that gives us our final answer of 1.08. And if we test it out, it would end up giving us positive answers. And that would work out. The last one, same idea. This one is actually the multiplication that we have to rewrite it because it's addition. So x times x plus 6 is equal to log of 27. If I rewrite this, I have log of x squared plus 6x equals log 27. And then we can just raise it to a base of 10 or rewrite it. And then now we're just going to go ahead and factor it out. So subtract 27, x squared plus 6x minus 27 equals 0. And now when I factor, because this one actually is nice and does factor, I get 9 and 3 over negative 9 and positive 3. And if I put in negative 9, you can see it would make this negative, and you can't have negative logs. So our answer is only x equals 3. If you have any questions, you could feel free to ask in class, sign up for T-Bolt time, or go to the center.